Good morning. So today we are learning about graphing linear equations in slope-intercept form. Our central question is, how do I find slope, which I'm sure you guys have found before, and graph lines in slope-intercept form? If you don't remember slope, that's totally fine because this is the perfect lesson to start with. So first things first, I want you to watch this video. It's called Slope Dude. All right, I have included a link in this video. Click on it. Watch it. Do not continue this video until you do. Okay, now that we've all seen Slope Dude, and I hope you really enjoyed it, I have fun with it, we want to talk about it a little bit. So it started off with a zero slope, right? That flat, easy to walk. And then we have a puff positive, right? So you're climbing up. And then we have a nice negative. And then we had our zero slope again, right? Because that's the easy zero. And then we had the worst word in algebra. Okay, it's the worst word ever. It's undefined. So let me give you an example of a zero slope, just so that you know what we're talking about. If you have a 0 over anything, all right, 0 over anything, that is okay. That equals 0. For undefined, that would be any number over 0. We cannot have that, all right? So this is undefined is a no, and 0 is okay, if that helps your brain. So here is our, how do we describe slope? We always use the variable m to describe slope, all right? So in all of our formulas that you'll see coming up for graphing linear equations, we're going to have m, and that's our slope. It's the rise over the run, change in y over the change in x. This delta right here, that little triangle, just means delta. It's a Greek letter, and it stands for change. Like, that's what it stands for. So if you ever see like a delta T, that's change in temperature typically. So we've got delta y, delta x, that means change in x, change in y. And then the one that you guys probably will use the most is this y2 minus y1 over x2 minus x1. It's probably the one you'll use the most. So typically you see m equals rise over run, or you see m equals y2 minus y1 over x2 minus x1. So we're going to practice this a little bit. The first one is just describing the slope. That's when we use our words, is when we describe. So here's my graph. I'm going to completely ignore this side. Okay, I'm just ignoring it. I want to describe this graph. Now, it doesn't matter which point you start with. I swear, it doesn't. You just need to pick a point. I like to start on my left because that's how I start reading, right? I read from left to right. So that's just how I read graphs too. So I'm going to start with this point. And when I describe this, not even caring about what the numbers are, I would say that I am moving down to, always start with your up and down first, no matter which point, start with your up and down. So I'm moving down to, and then I'm going right, 1, 2, 3, 4, 5. Well, down, is down positive or negative? I'm moving in the negative direction. And then right, is right positive or negative? It's the positive direction. So that means, according to my describing, it's negative 2/5. So I could rewrite that as negative 2/5. So now let's ignore the describing part. Okay, I'm covering that guy up. And now let's actually look at our numbers, right? So let's look at our numbers. I'm going to highlight my x's first. So I've got a negative 4 here and a 1. And then I want to highlight my y's. So I've got a 3 and a 1. And I am going to start with my y's. It doesn't matter which point I pick to be the first point and the second point. So I'm just going to make this one the second point. So I'm going to have 3, and I'm going to minus 1. And then I'm going to have negative 4 minus 1. Now here's what's really key, okay? Super duper key. This is 1 point. It is on top of each other in the formula, all right? Super key. They need to be on top of each other. Don't intermix your points, otherwise things go really bad. So make sure that when you see a point here, that they are stacked on top of each other here. So now I can do 3 minus 1. which would get me 2. And then -4 minus 1, that's really -4 plus -1, right? So just so you have that in mind. So that's really -5, which means this is a -2/5 all over again. So my point being, it doesn't matter which way you do it, right? It doesn't matter if you describe it or if you use points, you get the same answer. Very key. So now let's take a look at this one down here. Let's take a look at our second example. So again, I'm going to ignore the formula, and I'm just going to look at this and use my words to describe it. Again, I start on the left. So we're starting here. I am going up 1, 2, 3, 4. And then I'm going right 1, 2, 3, 4, 5, 6. That's all I'm doing. So an up 4 would be +4. A right 6 would be +6. That means I can rewrite this as 4, 6. But wait a second. I think I can reduce that down. I think I can make it easier. So I'm going to change this into 2/3 because that's the reduced form of that fraction. Fractions. I know you're super stoked. Who wouldn't be for fractions? All right, for our next one, we're actually going to ignore our description and we're going to focus on just the formula. So I'm going to highlight my y's and my x's. Again, it doesn't matter which point you start with first, so I'm going to pick this point to start first. No reason. So we have 3 minus -1, and then we have 3 minus -3. Now again, this is really key here. We have a point right here, and the point is stacked on top of each other in our slope. So I'm going to rewrite this because I'm minusing a negative, and I don't like that. Minus negative just, it throws me off. I know that when I minus a negative, I am really adding. So let's rewrite this as 3 plus 1, and then 3 plus 3. But when I do that, 3 plus 1 gets me 4, and then 3 plus 3 gets me 6. Hey, I can reduce that down to 2/3. Score, right? We got the same answer either way, which is awesome. All right. So we're going to do 2 of these together, and then I'm going to want you guys to try the rest on your own. So for this first one right here, we have, I'm just going to describe it. Okay, I'm just describing. So we are moving down 1 and then right 3. So that'd be -1/3. So that'd be -1/3. I always stick my negative out front. Okay, I'm going to tell you now on Big Ideas, it likes the negative out front for these fractions. Sometimes it'll accept it in the numerator, but not typically. So I just want to warn you now. Yeah, so FYI, just move it from the numerator or denominator out front. Let's take a look at our second one here. We are, let's go down here. So we are rising by 1, 2, 3. So up 3. Up 3, and then we are moving left 2. Okay, up 3 I know is going to be a +3, but left, we haven't seen left yet. When you move left, you're actually moving in the negative x direction. So this is going to be a -2. So when I rewrite this, it's going to be -3/2. All right, that's the slope for this equation is -3/2. All right, I want you to take a minute to try these 2 on your own. All right, try these 2 on your own. And then once you've done those, let's check our work. So for this one, we should have gone 1, 2, 3. So that's up 3 and then right 1. So that'd be 3/1, which is the same as 3. For this one, we are going down 1, 2, 3 and left 2. Well, that'd be -3/2. Hey, wait a second. Negative divided by negative is a positive. So that'd be +3/2. Some of you might have gone up 3 and right 2. So my point here being you can go either direction, right? Doesn't matter which point you start with as long as you are rising and before you run. And again, you could rise, you could go down. It's just meaning in the y direction. All right, try these ones out for yourself. All right, try these ones out for yourself. Okay, So now that we've practiced a little bit, at least, these answers are in my notes, so feel free to double check your work. Let's take a look at what do we do if we have a table or if we have some points. How do we do that kind? So for a table or some points, what we need is our formula, right? We don't have an easy way to just read the graph now. We actually have to use our formula. When you have a table, you actually have multiple points. Every line is a point. You only need 2 of them. All right, you only need 2 points. It doesn't hurt to double check and make sure this actually is a function. So for example, we've got 4, 7, 10, and 11. No x is repeated. Yes, it's a function. I know, just bringing that back in. It's important to know. So now that we know it's a function, let's just pick 2 points. I'm going to pick this one and this one. So let's start with our y's. So I'm going to have 14 minus 8, and then I'm going to have 7 minus 10 for my x's. Well, 14 minus 8 is 6, and then 7 minus 10. The 10 is bigger, so it's actually going to be a negative 3. But when I do that, 6 divided by negative 3, I get negative 2. So that is my slope, negative 2. All right, so try this one on your own. Pick 2 of the points. Doesn't matter which 2. And then we'll check our work in a sec. All right, I'm going to pick this one and this one. So make sure your answer is the same as mine. All right, doesn't matter which 2 points. We should get the same answer. So I'm going to do 2 minus 2, and then I'm going to have 3 minus 5. Well, 2 minus 2 is 0. 3 minus 5 is a negative 2. 0 divided by negative 2 is okay. You should get 0. All right, the next one let's try is this one. So let's do 14 minus 10. So 14 minus 10, which means I need to have negative 7 minus 8, right? I started with this one. This point is on top of each other. It's perfect. So we've got 14 minus 10 gives us 4. Negative 7 minus 8 is really negative 7 plus 8, negative 8. So that gets us negative 15. So when I rewrite this, it would be negative 4/15. All right, there are 5 more on this page. I want you to try the next 5. Okay, try the next 5. And then use my notes. Actually, we'll go over these 3 together for sure, but I want you to try these 2 down here all on your own. No help, no color coding. Okay, so for this one, you should have 2 minus 1, negative 17 minus negative 3. So that gets you 1 over negative 14, because this is really a plus 3. For over here, you should have negative 10 minus negative 4, and then 12 minus negative 20. These really turn into adding, right? Plus minus negative is a positive. So we get negative 6 over 8, which is negative 3/4. For this one, we should have negative 8 minus negative 5, and then 0 minus negative 12. Those turn into pluses. So we end up with negative 3 over 12, which would be the same thing as negative 1/4. All right, for these ones down here, you should have 16 minus negative 6 over 15 minus negative 19. So that gets you 22, because these are really addings then, over 34. And then for this one, you should have 9 minus negative 9, and then negative 6 minus 7. This turns into an adding, so it gets 18 over negative 13. So that'd be negative 18/13. Fractions are your friend. Email me if you have any questions. Skills Practice is posted to Big Ideas.